Hello. Hello. You're welcome to BRAINX TV for our live class this evening. Thank you for joining. Please, please write the name that you want to be addressed with in the comment section, so that you'll be addressed as such. I have Boahima. Boahima, please, you can write up the name that you want to be addressed with in the comment section, so that you'll be addressed with such name. Okay, Boahima is great. Okay, thank you for joining the class. Thank you. Please, let's get started. Let's get started. We have about 60 minutes for this class. So please, let's get started. And please, if you have not subscribed to BRAINX TV, please subscribe to BRAINX TV. And as well, like the videos, like the class, and share the link of the videos to your friends as well. The BRAINX TV is live this evening. Hi, Cheryl. Welcome. Thank you for joining. So, you're welcome. You're welcome to BRAINX TV. Take it back. Can you move it back a bit? I want to see how it looks. Go back again. All right. Okay. Margaret, thank you for joining the class. Thank you. All right, so please let's get started, okay? Let's write our topics for this evening down and let's get to it. Okay. Hi everyone. Thank you for joining the class this evening. We are going to consider these topics, okay? These are topics we're going to consider for the evening. We're going to have fractions and we are going to consider addition and subtraction of fractions, as we're going to look at multiplication of fractions. And finally, we're going to look at ratio. So these are the three main topics under consideration this evening. So please, let's join, share the link to your friends, and let them join so we can start. All right, so let's get started with fractions, okay? We'll look at addition and subtraction of fractions. So with addition and subtraction of fractions, we're going to consider like fractions and unlike fractions, okay? Let's start with like fractions. So we have 2 over 7 plus 3 over 7. Let us try solving this work out. You know, this moment is a discussion that we're going to do. So please do well to use the comment section and let's get involved. All right, Fadila, thank you for joining the class. You're welcome. So let's use the comment section to get interactive in the class, okay? So we are starting with addition and subtraction of fractions. We're looking at like fractions. So we have 2 over 7 plus 3 over 7. Oh, okay. Thank you for your answer, Craig. Anyone else, please, let's get interactive in the class. Let's get very interactive. Okay, Cheryl, thank you for your reply as well. Please share the link of the videos to your friends as well to remind them that BRAINX TV is live. Okay, Margaret, thank you for your input as well. So let's get to our solution. So since we have like fractions are fractions that have the same denominators. Okay, so since 2 over 7 and 3 over 7 have the same denominators, we are only going to add up the numerators. All right, so this is going to give us 2 plus 3. Because the denominators are the same, we choose only one of them, okay, as our denominator. So we get 2 plus 3 divided by 7, okay, and 2 plus 3 is equal to 5 over 7. So the solution to our work is 5 over 7, okay. Thank you all for your inputs. I'm sure this is Babette. Thank you for joining the class. Thank you. Let's get to work. Let's look at an example. We have 13 over 25 minus 6 over 25. Please, let's find the solution to this work as well. 13 over 25 minus 6 over 25. Okay, Babette. Hi, Babette. Thank you for joining the class. Okay. Craig is giving us 7 over 25. Yes, who else? Please, let's try our best to answer the questions. So if there's any error, we will all correct it, okay? Okay, Cheryl, Maggie, all right, thank you all for your input. Please, let's get interactive in the class. All right, so since this question also contains like fractions, I'm going to write one of the denominators and work out the numerators, okay? So it's going to give us 25. Then we subtract the numerators, 13 minus 6. And 13 minus 6 is equal to 7. And 7 is equal to 7 over 25. Thank you all. Alright, let's move on. Let's look at mixed fractions that have like fractions attached to it, okay? Mixed fractions that are like fractions. For example, so we have 4 whole number 6 over 19 plus 2 whole number 8 over 19. So let's find a solution to this work. Let's find a solution to this work. 4 whole number 6 over 19 plus 2 whole number 8 over 19. So anyone with the answer? Yes, anyone with the answer? All right. So Cheryl is giving us 6 whole number 14 or 19. Okay, that's correct. Okay, Babette, thank you. Thank you for the input. Yes, who else? So let us all try up, okay? Let us all try to get involved. Okay, so with this, we are going to work out the whole numbers and the fraction. Okay. We're going to add the whole numbers first, and we add up the fractions. So we are getting 4 plus 2 for the whole numbers, and then 6 over 19 plus 8 over 19 for the fractions. Alright. So 4 plus 2 here gives us 6. We get 6 plus. Since these fractions are like fractions, we are just going to write one of the denominators and add up the numerators. This will give us 6 plus 8. Okay. So we are going to get the next answer to be 6 plus. Now 6 plus 8 is 14. So 14 over 19. And what else becomes 6 whole number 14 over 19. I hope you all got the same answers. Okay, Maggie give us this one over 14 over 19. Craig also gave us this one over 14 over 19. Babette, Cheryl. All right, thank you all for your inputs. Now let's move on to unlike fractions. So this is for like fractions. Let's move on to unlike fractions. Okay. So our fourth example. Two over 5 plus 3 over 7. Alright, how are we going to solve this? Please note that the denominators are not the same. So we have to work these denominators out to get a common denominator to both 5 and 7. Okay. Alright. So we're going to find our LCM. We're going to use a very simple approach in finding the LCM. So you're listing the multiples of 5 and the multiples of 7. Okay. So we start with 5. What are the multiples of 5? Please, let's list some of the multiples of 5, okay? Let's list some of the multiples of 5. Okay. One of us has already taken the lead in giving us the answer. Thank you. But let us work it out together, okay? So the multiples of 5. Okay, Craig is giving us his input. Thank you. Please, who else? The multiples of 5. The multiples of 5. Okay, so let's them up. So we have 5, 10, 15, 20, 25, 30. Let's get some more. 35, 40, 45, and so on. Now let's say that of 7. So for 7 we have 7, 14, 21, 28, 35. However, you can see that you come across the number, the first one that is common to both numbers, okay? And that is 35 and 35. Alright, so that implies that our LCM is 35. Does everyone understand? Okay, so write our LCM now as 35. Now, after getting your LCM, you're going to check the number of times each denominator will divide the LCM. When you get your answer, you will multiply it by the corresponding numerator. Okay. So we ask how many times will 5 divide 35? One of the ways is we can count the number of times we go to 35 as our answer. And it's very simple and clear. Okay. So 5 we have 1, 2, 3, 4, 5, 6, 7. That implies that 5 will divide 35 7 times. So multiply 7 by 2. So this will give us 7 times 2. Does everyone understand? Then plus, how many times was 7 divided 35? That's going to be, let's count and see. 1, 2, 3, 4, 5. So 5 times. Then multiply 3 by 5. So you get 5 times 3. Does everyone understand? So we looked out for the LCM, which is 35. Then we check the number of times each denominator will divide the LCM. Then we multiply the corresponding numerator by the answer we get. So the 5 will divide 35 7 times because we have 1, 2, 3, 4, 5, 6, 7. On the seventh number we have 35. So I divide 35 7 times. Multiply 7 by the numerator here, which is 2, plus 7 divides 35, 1, 2, 3, 4, 5, 5 times. Multiply 5 by 3 over here. Alright, so let's make progress. Now 7 times 2 gives us 14. So you get 14 plus 5 times 3 gives us 15. All divided by 35. And 14 plus 15 is equal to 29 over 35 as our final answer. Okay. All right. So, Craig, you brought your answer. Cheryl, you brought your answer. Okay. Babette, you brought your answer. Fadila, please check your answer. Okay. Please check your answer and add up well. Okay. Please check your answer. If there's any part you don't understand, please write in the comment section that I don't understand and I'll go over for you. Oh, so sorry for the poor network. So sorry about that. Please, I hope the network has been restored. Okay. Thank you. So let's get to our fifth example. That's what we have over there. 1 over 4 plus 3 over 6. So what will be the LCM? Let's work this together. What will be the LCM? So what's the LCM? Well, you can see that. So let's do the same operation in finding our LCM, okay? We get that of 4 and 6. So the multiples of 4 we have 4, 8, 12, 16, 20, and so on. Okay. That of 6 we have 6, 12. See, the LCM is the first common number that we encounter. Let's see that we have 12 with 4 and 12 with 6. That implies that our LCM is 12. Okay. So our LCM to be 12. So after getting our LCM, we check the number of times each denominator will divide the LCM. So sometimes with 4 divide 12. And we count, we have 1, 2, 3. So that means 4 divides 12 3 times. Okay. So multiply 3 by 1 over here. So you get 3 times 1. Plus 6 divides 12, 1, 2 times. Multiply 2 by 3. You get 2 times 3. Does everybody understand it? Alright, so we are going to get 3 times 1 is equal to 3. So you get 3 plus 2 times 3 is 6. All divided by 12. Okay. Now, 3 plus 6 is equal to 9 divided by 12. I hope you're getting the same answers. Now, we have to simplify our answer. Well, there's a common number to 3, to 9, and 12. So let's simplify it in the comment section. Please let's get active on the comment section to simplify the fraction 9 over 12. Okay, Babette, I see your input. Cheryl, Craig, thank you all for your contributions. Please let us all get involved, okay? Okay, Margaret, thank you for your input as well. Thank you. Okay, so you can see that the common number to 9 and 12 is 3, okay? So how many times will 3 divide 9? 3 divides 9 3 times. And 3 divides 12 4 times. It's going to be 3 over 4. Does everyone understand it? Alright, let's move on to our sixth example. Now we're going to look at adding, subtracting unlike fractions. Okay, subtracting unlike fractions. So let's do this. Number 6. 3 over 5 minus 1 over 4. 3 over 5 minus 1 over 4. Let us find solution to this work. Let's get interactive over here. 3 over 5 minus 1 over 4. We're going to subtracting unlike fractions. So we have 3 over 5 minus 1 over 4. Okay, so we are getting our answer to be 7 over 20 from one of our friends. Yes, who else? Who else? Please let's get to work and provide our answers, okay? So let's get to the solution. I'm going to look out for our LCM for 5 and 4. Now, LCM for 5 and 4 here is 20. Okay, so let's show how we got the 20. Now that's of 5 and that's of 4. You have the multiples of 5 to be 5, 10, 15, 20, 25, and the others. Then that of 4 gives us 4, 8, 12, 16, 20. So we're getting to the first common number to 4 and 5 to be 20. Okay, so that our LCM is 20. That's what we're over here. Now we take the number of times 5 will divide 20. We have 1, 2, 3, 4. So 5 divided 20 4 times. And multiply 4 by 3. So this gives us 4 times 3 minus, take the number times 4 will divide 20. And that is 1, 2, 3, 4, 5. So 5 times. Multiply 5 by 1. So 5 times 1. Now 4 times 3 here is 12 minus 5 times 1 is 5, all divided by 20. Okay. And 12 minus 5 is 7 over 20. Good. Sarah, thank you for your input. Margaret, okay. Craig, Babette. Thank you all for your contributions, okay? I really appreciate it. Thank you so much. Now let's try the next example, which is going to be unlike fractions. Subtracting unlike fractions and mixed fractions as well. So we will take this. Number 7. Five whole number 4 over 7 minus 2 over 1 over 4. Let's try this our 7th example. Alright, so let's try our 7th example. We have 5 whole number 4 over 7 minus 2 whole number 1 over 4. Alright. Okay, so Sharon is giving us 9 over 28. 9 over 28. Please check your answer for us. So we have 5 whole number 4 over 7 minus 2 whole number 1 over 4. So please check your answer, okay? I'm not sure it's very... So you just check it up, okay? Alright, so let's get to it. So over here, we're going to subtract the whole numbers and we'll subtract the fractions. Okay. So we get 5 minus 2 for the whole numbers plus 4 over 7 minus 1 over 4 for the fractions. Okay. Alright. Now 5 minus 2 is equal to 3. So we get 3 plus. We are going to work out 4 over 7 minus 1 over 4. Alright. So here we go. We're going to find our LCM for 7 and 4. What is LCM for 7 and 4? The LCM here is 28. You can use this approach to work out the LCM, okay? The LCM here is 28. Now, how many times was 7 divided 28? 7 divided 28 4 times. So multiply 4 by the numerator 4 by as well. So you get 4 times 4. Then minus, you say 11 times 4 will divide 28, and 4 divided 28 7 times. Multiply 7 by 1, then minus 7 times 1. Okay, this is going to give us 3 plus. Now 4 times 4 is equal to 16. So 16 minus 7 times 1 is equal to 7. All divided by 28. Okay, this is now going to give us 3 plus 16 minus 7 is equal to 9. So 3 plus 9 over 28. The abundance is going to be equal to 3 whole number 9 over 28. Did I hope you understand it? All right, Babette, thank you for your input. Thank you very much for your input. All right, Craig, thank you for your answer as well. Thank you so much for joining the class. Now we are moving on to multiplication of fractions, okay? I hope by now we've understood very well addition and subtraction of fractions, both like and unlike fractions. All right, so let's get to multiplication of fractions. We are multiplying a fraction by a fraction. This is the first one. Fraction by fraction. We are multiplying a fraction by a fraction. Let's take this example. Alright, so we have 7 over 15 times 20 over 35. Now, looking at this question, we are going to look at the common numbers that exist between the numerator and the denominator. Please note that we are going to look for common factors between the numerator and the denominator. Please, not numerator denominator or numerator numerator. Okay. Look at the numerator and the denominator. Look for any common terms that exist between them. Please note, we don't find LCM when multiplying fractions. Okay. There's no way you're going to. If you find LCM when multiplying fractions, your work could be wrong. All right. So we don't find LCM when multiplying fractions. All right. We only cross out or cancel the common terms between the numerator and the denominator. Okay. All right. So considering 7, let's say for 7 in the denominators, see which of them, whether common factors exist. Okay. We check for 7 and 15. 7 and 15 do not have any common factors. All right. Then we check for 7 and 35. We check for 7 and 35. You can see that 7 and 35 have a common factor, which is 7. Okay. So we're going to cross out a common factor. So 7 divides 7 once. 7 divided 35 5 times. So you understand it. And so we're now getting 1 over 15 times 20 over 5. Then we check again if there are any common factors to the numerator and the denominator. Now, since this is, so I'm not going to use 1 again. We're going to the numerator here, 20. Does 20 have anything to do with 5 or any common factor to 5? Yes, and you can see that 5 can divide 20 and 5. Okay, so 5 divides 20 4 times and 5 divides 5 once. Alright, so this answer is going to give us 1 over 15 times 4 over 1. Now we check again. The numerator and the denominator, whether there are any common factors. You can see that 4 and 15 do not have any common factors. Alright, so 1 is common to 1, and we don't use 1 as a common factor. Because 1 is a common factor to every number. So we're going to multiply our answers. So multiply the numerator by the numerator, and the denominator by the denominator. So 1 times 4 gives us 4. Over 15 times 1 gives us 15. So this becomes our final answer. Without that is okay. Please, I hope it's okay. Okay. So Fadila is giving us 4 and 15. Sharon is giving us 4 and 15. Okay. Craig is giving us 4 and 15. Thank you. Then Babette is also giving us 4 and 15. All right. Then Margaret as well is giving us 4 and 15. Thank you. Thank you all for your contribution. I'm so grateful. So let's try another example. So let's try this one. The second one. 5 over 9 times 3 over 25. Let's try this together. 5 over 9 times 3 over 25. Let's try this. Alright, so what are we getting for our answer? 5 over 9 times 3 over 25. Alright, so Sharon is giving us 3 over 5. Okay. Oh, Anaya, thank you for joining. So you are giving us 4 on 15. Okay. Okay, so Fadila is giving us 1 on 15. Anaya is giving us 1 on 15. Maggie, Babette, Craig, Cheryl. Alright, thank you all for your inputs. I'm so grateful for your engagement this evening. So let's find solution to the word. So we're going to consider the numerator and the denominator to check if there are any common factors between them. Okay. Now let's get out of 5. Now 5 and 9 do not have any common factors. Okay. So check with 5 and 25. Instead 5 and 25 have a common factor of 5. Okay. So 5 divides itself once and divides 25 5 times. Alright. So this will now give us 1 over 9 times 3 over 5. Then we check again. Where there are any common factors. So we get a lot of 3. 3 and 5 do not have any common factors. So we're checking with 3 and 9. 3 and 9 have a common factor of 3. Okay. So 3 divides 3 once and divides 9. So that we get 1 over 3 times 1 over 5. And 1 times 1 is equal to 1 over 3 times 1 is equal to 15. So all of you give us answer to be 1 over 15 is correct. Thank you so much. I'm very grateful. Let's take another example. That looks at multiplying a fraction by a whole number. Okay. So let me write the heading here. So fraction number 2. Fraction by whole number. So what kind of fraction by whole number? For example, 7 over 18 times 12. 7 over 18 times 12. Now, with this, it can be easily solved. If you think you get confused with the whole number, every whole number has a denominator of 1. Okay? Every whole number has a denominator of 1. If we're going to rewrite this our question to make it a fraction, so it will look like multiplying a fraction by another fraction. Okay? This is going to give us 7 over 18 times 12 over 1. Okay? So that we will get the ease of it as if you are multiplying a fraction by another fraction. Alright? So with this, we're going to consider the numerator and the denominators to see if the numbers can cancel or if there are any common factors. So 127 and 18 7 and 18 do not have any common factors. Okay. And 7 and 1 have a common factor of 1. And we don't use 1 to cancel out the numbers. Because 1 is a common factor to every number. Alright? So we will check for 12 and 18. I mean, you can see that 12 and 18 have a common factor, which is 6. Okay. So 6 divides 12 2 times, and 6 divides 18 3 times. So this is now giving us 7 over 3 times 2 over 1. Okay. Alright. Then I said there are no common factors to the numerator and denominator anymore. So we proceed to multiply. So we multiply the numerator by the numerator and denominator by the denominator. Now 7 times 2 is equal to 14. So 14 over 3 times 1 is 3. That's equal to 14 over 3. But you cannot leave your answer as an improper fraction. You're going to change it to mixed fraction. What will the mixed fraction for 14 over 3? Please use the comment section and let's get the mixed fraction of 14 over 3. Yeah, so please, what do we get for 14 over 3 as a mixed fraction? Yeah, so what do we get? What are we getting for 14 over 3 as a mixed fraction? Okay, Craig is giving us 4 whole number 2 over 3. Thank you. Four number 2 over 3. Please, who else? Please, let's get interactive, okay? Let's get interactive. Okay, Fadila, 4 number 6 over 9. Okay, but you can further simplify it, okay? And simplify the 6 over 9. So please try that one for us. Simplify the 6 over 9 for us so I can get our answer in the simplest form. Oh, okay, you don't understand. Oh, okay. Let me go over for you, okay? So please pay attention. We have 7 over 18 times 12. Okay. We want to rewrite our whole number as a fraction. And to do that, we just divide the whole number by 1. So we now get 7 over 18 times 12 over 1. Alright. Now, we look out for our common factors. And we saw that 6 was a common factor to 12 and 18. So 6 divides 12 2 times. 6 divides 18 3 times. And apart from this one, no other numbers are. There's no other common factor. Okay. Then we proceed to multiply. So we get 7 over 3 times 2 over 1. And 7 times 2 gives us 14. 3 times 1 gives us 3. I want to write 14 over 3 as a mixed fraction. Which I hope you understand now. Babette and Cheryl. Please, is it clear? If it's not clear, please let me know, okay? All right, Maggie, thank you for your input as for number 2 over 3. Thank you. Miss, are we good to go? My two friends who don't understand. Hello, please, do you understand now? Okay, so Babette has not gotten to understand now. What about Cheryl? So our best question is giving us 3 divides 14. Let's do the repeated subtraction approach, okay? Now we're going to subtract the denominator from the numerator until our answer we get is lesser than the denominator. So it's giving us 14 minus 3. The first one is equal to 11. 11 is not lesser than 3. So we subtract again. We get 11 minus 3. 11 minus 3 is equal to 8. Still, 8 is not less than 3. So we subtract again. We get 8 minus 3. 8 minus 3 is equal to 5. Okay. And see that 5 is still not lesser than 3. So we subtract again. We get 5 minus 3. 5 minus 3 is equal to 2. You can see that now 2 is less than 3. So we can stop over here. Now how many times do we subtract 3 from 14? But 1, 2, 3, 4. So 4 times. That gives us 4 whole number. And the remainder was 2. So 2 over 3. This is the mixed fraction for 14 over 3. Is that what I understand? Now let's move on. Our 60 minutes is up and we've not even started doing ratio. So let's get to ratio. But before that, let's take one word problem under fractions, okay? One word problem under fractions. A very quick one. All right, let's take this word problem, okay? The question reads, okay, before we get to our question, let me address some challenge over here. Sharon is asking, Seb, please, can't you use 3 to divide 18 and 12? Yes, you can. When you use 3 to divide 18 and 12, still, you have to use 2 again to divide it. Okay? So it's not that you should use only 6. You can use 3. Okay? But when you are done using the 3, you will still have to break it down again using 2. That's how come we used 6 straight away. All right. So please take note of that for me. After using 3, you will still have to use 2 again to divide. That's how come we used 6 straight away. And Anaya, please check your answer, okay? 1 over 3 over 4 is not correct. So please check your calculations again. All right, now let's move on to our word problem, okay? And it reads, Emilia spent 2 over 7 of her pocket money on food. Okay. She also spent 3 over 5 on transportation. Sorry. On transportation. The first question is, what fraction of her money was spent? What fraction of her money was spent? That's what we can calculate for. So please listen and listen very well. She spent 2/7 on food and 3/5 on transportation. So these are the 2 fractions that she spent. So to find the total expenditure, we want to add up the 2 fractions. Okay. So this is going to give us 2 over 7 plus 3 over 5. Does that understand? Anaya, please hold on and WhatsApp me after the class, okay? So that I will further explain things to you. All right. Okay, so let's continue. So you have a word problem, and the question is, what fraction of her money was spent? Emilia spent 2 over 7 of her pocket money on food. She also spent 3 over 5 on transportation. Now the question is, what fraction of her money was spent? Okay, what fraction of her money was spent? And we've seen that for you to know the fraction that was spent, you have to add the 2 fractions that were spent together. Okay, so we have 2 over 7 plus 3 over 5. And let's find a solution to that. 2 over 7 plus 3 over 5. Okay, so with this one, we are going to look at the type of fractions that are here. So they are unlike fractions. You cannot just add unlike fractions unless you look out for the LCM. Okay. Alright, so this will give us our LCM, which is 35. Okay. We just solve a question like this. So when you are done, you can even go back and replay the video. Okay. You can understand it better. Now, how times was 7 divided by 5? It's going to be 5 times. Multiply 5 by 2. So you get 5 times 2 plus 5 divided by 5 7 times. Multiply 7 by 3. So plus 7 times 3. Okay. Alright. Now this is giving us, let me extend our board here. Now 5 times 2 is equal to 10. You get 10 plus 7 times 2 equals 21. 21 all over 35. Okay. And that plus total is equal to 31 over 35. Does everyone understand it? Okay. All right, Craig, thank you for your input. Cheryl, all right, thank you. Babette, thank you. Thank you so much for the engagement. Thank you. All right. Now let's get to the second question. All right, so it says, what fraction of her money is left? What fraction of her money is left? Now we have seen that she spent 31 over 35. So we are not given any amount to her. So how are we going to find the fraction for the amount of money left? Now that's what we do. In fraction, we said a fraction is a part of a whole. So we always take it that the whole fraction we're talking about is 1. So regardless the amount that you are dealing with or whichever quantity you are dealing with, we take the total of fractions to be 1. Okay. So we will take it that the money that she had on her was 1. Then she has spent this out of the 1. So you're going to subtract 31 over 35 from 1. Okay. So this is going to give us 1 minus 31 over 35. Does everyone understand it? We are saying that the total money that she had is considered to be 1. Alright. Don't forget to have learned that a fraction is a part of a whole. And by the whole, we mean what? One whole thing. So 1. We are taking part of it. That's the fraction. So if she has spent 31 over 35 from her pocket money, then the whole pocket money here is 1, and the fraction spent is 31 over 35. So we're going to subtract what she has spent from the total amount of money that she had. Alright, so that gives us 1 minus 31 over 35. Now, we said that you can change a whole number to a fraction. So you can easily work out with it. Okay, and we can do so by dividing the whole number by 1. And it becomes a fraction. Because every whole number has a denominator of 1. This is not going to give us 1 over 1 minus 31 over 35. Is that okay? Alright. Now, since these two fractions are unlike fractions, we're going to look out for the LCM. Look for the LCM of 1 and 35. So the LCM of 1 and 35 here is 35. Okay. The LCM of 1 and 35 is 35. So we're going to check how many times 1 will divide 35, and then we also divide 35. Now 1 divides 35 times. What about 35 by 1? So we get 35 times 1. Okay. Minus 35 divided by 35 once. So multiply 1 by 31. So we will get minus 1 times 31. Alright. Now this is going to give us 31 times 5 is equal to 35. So we get 35 minus 1 times 31 is 31. So 31. All divided by 35. Okay. Now 35 minus 31 is equal to 4. So that is equal to 4 over 35. So this is the fraction of the money that was left. Please, I hope you understand it. Let me know it up in the comment section. Does that understand what we've done so far? And with regards to finding the fraction of the money that was left. Please let me know your concerns in the comment section. Please, at this point, if you have not subscribed to BRAINX TV, please do well to subscribe to BRAINX TV on YouTube, okay? So that we can be learning mathematics with ease, just as we are seeing this evening. And as well, please make sure you like the video, okay? Like the video as well, and write comment on anything. For anything you don't understand, write up in the comment section and it will be addressed to your utmost satisfaction. Please like the video, and subscribe to BRAINX TV. Please like and subscribe, like and subscribe. Like and subscribe, please. Like and subscribe. Are we good to go? All right, let's then get to our final topic for the night, ratio. Okay, then we can call it a day. Ratio. If there's no question with respect to what we've done so far, then let's get to ratio. Okay, okay, you are confused. Okay, let me go over for you, okay? The confused one and the confused ones. Please let me go over for you. So pay attention. All right. We have calculated for the fraction that was spent and what is 135. Now, we have to look out for the fraction that is left because she was given some money and she spent some and she has some left. So what fraction is left? So this is what we do. We will take it that, okay, let's take an example like this, that you've been given an amount of money to be brought to school. So you send the money to school, you buy food and you take car to school. Now, how much have you spent? You're going to add the cost of the food you bought to the cost of the transportation to get the total amount of money that you have spent. Okay, it will be the same idea that we solved this question with. We added the cost of food, the cost of transportation to get the total cost or the total amount that was spent. All right. Now, how do we know the amount left? So, I do you want to take change home? How do you know the change you are going to take home? You are going to do so by subtracting the cost of the food and the transportation from the total amount of money that was given you. Now, in fractions, we always take it that the total amount given you is 1. Okay? The total amount given you is 1. So, and you have spent 31 over 35. You're going to subtract 31 over 35 from 1, which is the whole amount of money that was given you. Because I hope you understand it. That is the whole amount of money that you were given. Alright. So we subtract 31 over 35 from 1. That's 1 minus 31 over 35. Now we can express a whole number as a fraction. Because every whole number has a denominator of 1. Okay. So we now write 1 as 1 over 1 minus 31 over 35. Then from here we calculate for the LCM. So the LCM was 35. Now we ask ourselves the number of times 1 will divide 35. 1 divides 35 times. So we multiply 35 by 1. That's why we get 35 times 1. Alright. Minus 35 divides 35 once. Multiply 1 by 31, so we get 1 times 31. Now 35 times 1 is equal to 35. Minus 1 times 31 is equal to 31. All divided by 35. And 35 minus 31 is equal to 4 divided by 35. Is that you understand now? Please, are you still confused? Yes, so the answer is 4 over 35. Thank you. Thank you so much, Craig. There's the confused ones. Are we good to go? Okay. So I've gotten a yes, then it means we can make progress. All right. Thank you so much, Cheryl. Well understood. All right. Thank you. Thank you very much. What about Anaya? Do you understand it now? Let's look at ratio. Okay. Our time has passed. Okay, Kweku. Welcome. Okay. All right. I now understand. All right. That is fine. Kweku, welcome. It's like you didn't come early today, but the class has not ended, so you can still enjoy some lessons. Okay. Ratio. That's our last topic for the night. Ratio. 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 Now, what is ratio? What is ratio? Yes, let's brainstorm. What is ratio? All right, Anaya, I'll get to you, okay? I'll get back to you. All right, you let's continue. I'll get back to you. All right, so Craig is giving us the input that it is comparing two numbers together. Well, comparing two numbers or two quantities, that is true. Comparing two quantities. But please note, you're comparing two quantities of the same unit. Okay, of the same unit of measurement. All right. So, comparing two or more quantities of the same unit of measurement. That is fine. Now, in ratio, you always have to simplify your ratio. Make sure you do away with all the common factors in your work. Okay. Let's take an example like this. That in a classroom, let's just build a classroom. There are 12 boys. There are 12 boys and 16 girls. Okay. This is the classroom. There are 12 boys and 16 girls. And I trying to find the ratio of girls to boys. Okay. Find the ratio of girls to boys. Now, ratio here is represented using three forms. You can use the colon sign to represent ratio. Okay. Like example, 16 is to 12 from our question. Okay. Ratio of girls to boys. Whether 16 is to 12. Or you can use word. Using the word is to. Or 2. Alright. And the word is to. Or 2. Okay? 2 as a form of ratio. We can write ratio as a fraction. So 16 over 12. This is my 16 is to 12. Okay, you can write ratio as a fraction. Alright. Now in ratio, when you're comparing the quantity that comes first, should have age representation coming first. So you have been told that there are 12 boys and 16 girls in the classroom. And find the ratio of girls to boys. So since it is girls to boys, you cannot write the number of boys first. If you do so, the record will be wrong. You have to write the number of girls first before the number of boys. There are 16 girls, so you get 16 is to, number of boys is 12. So 16 is to 12. So if you get it, 16 is to 12. Please write it as 12 is to 16. The record will be wrong because you were told that find a ratio from girls to boys, not boys to girls. So the value of girls should come first for the value of boys. Do you understand it? Alright, and after this, you check whether there are common factors to the two numbers and you simplify. If you don't simplify your work, it is wrong. Right, so always do what to simplify. So whichever is common to 16 and 12? Whichever is common to 16 and 12? Alright, so I'm back here. I've seen your comments from Margaret, from Cheryl, and from Babette. Alright, thank you all for your input. Adam, I'll get back to you, okay? I'll get back to you. Alright, now Cheryl, you can use 2 or 4. Any of them is correct. Okay. Alright, so let's go. Now, which number is common to 16 and 12? You can use 2. Okay. How times to 2 divided 16? 2 divided 16, 8 times. And 2 divided 12, 6 times. So 8 is to 6. Do we still have any common factors to 8 and 6? Yes, and that is 2. Alright. So you have to simplify it better. Because it should be in the simplest form. Alright, it should be the simplest form. So 2 divided 8 4 times, and 2 divided 6 3 times. So our final answer is 4 is to 3. Does everyone understand it? And another question can be put this way. This for the first one. Second one, find boys to the total number. Okay, find boys to the total number. Now, what is the total number of pupils in the classroom? That's what is demanded of you when you say the total number. Okay, we're going to calculate for the total number of students. So we do so by adding 12 and 16. Okay, so we get the total is 12 plus 16. The number of 16 is equal to 28. Okay, so for our ratio, we have boys to total number. How many boys are there? 12 boys are there. What's the total number? 28. So our ratio becomes, yes, write the ratio in the comment section. There are 12 boys and the total of 28 learners. So what will be the ratio of boys to the total number of learners? What will be the ratio? All right, Google is giving us 12 is to 28. Margaret is giving us 12 is 28. All right. But please do what to simplify your answers. Do what to simplify your answers, okay? Okay. Cheryl is giving us 3 to 7. All right. Thank you. Twelve to 28 from Fadila. All right. But please do what to simplify if you can. All right. Let's move on. So we will get number of voices 12. Total number is 28. So we get 12 is to 28. Okay. And so we can simplify 12 and 28. So 4 is common to 12 and 28. 4 divides 12 3 times, and 4 divides 28 7 times. Okay. So our final answer is 3 is to 7. Is that you all understand? Alright. So our time is almost up for up to 90 minutes. And we will have to bring our class to a close because we are doing 60 minutes and we've now done 88 minutes. So we have to bring our class to a close. Okay, all right. So let's do a quick recap of what we've learned so far. Look at addition and subtraction of fractions for both like and unlike fractions, and as well multiplying fractions by a fraction by a fraction and a fraction by a whole number. Okay, and we solved one word problem under fractions, for which we applied addition and subtraction of fractions. And now we count our lesson here with ratio, being the unit of comparing two or more quantities of the same unit. Okay, we define ratio as comparing two or more quantities of the same unit. And we've taken one example under it, and we have looked at two different answers. And noted that ratio should always be simplified. Your answer in ratio should be simplified. If there are no common factors, you simplify them before you write your final answer. And this brings us to the end of our lesson for this evening. I hope you enjoyed yourself. We will meet some other time to continue learning. See you at another time. Please do what to subscribe to the channel if you have not, so that whenever there is going to be a class, you'll be notified by YouTube that the class is coming on, then you will join. Then we can together say that mathematics is the easiest subject ever to be taught in schools. See you another time. Bye.